This has never happened before, Grace. Everything's falling apart today.
It is just falling apart today. It's not trying to cooperate.
All right. Well, I can walk you through this part. But so we can't use SPSS data, so we have to transform it into a DAT file. So the first thing we do in SPSS, we turn all our missing into -99s or any other number that doesn't exist in your data. Then you save that as, instead of SPSS, you can save it as tab delimited. So we save it as tab delimited. In the next line below, it's encoding. We go to the bottom one that says local encoding, and we click that. We unclick the save variable names. We unclick the save variable names because we don't want the names of the variables on the top. We only want numbers there. And then when we've got our DAT file, then we're good to go. And that DAT file is what M+ uses to read our data. I'll skip ahead. Imagine if we did it this fast to start off with. There it is. All right, so once we have our DAT file, then we click here on Browse, and we go to find where that DAT file was saved. Then we open up our DAT file, and press Next. And we click Free Data Format, that there is missing data, that the missing data is numeric. And we click Next. I don't write my real variable names in, I just write x1 as a placeholder, then click Add, and it moves over. And then use variables, same thing, add to move it over. This doesn't help you now until you're actually doing it yourself. But when you're doing it yourself, this is what we click to go through. For missing, we say same for all variables, and we write in that -99. So it knows everywhere it sees a -99, that's a missing variable. Then next, if you're using a weight variable, some of your data sets are weighted. If you're using add health, or some of them have weights to make it more nationally representative. Then next, I click these top 4 for the output that we want, standardized betas, modification indices. Then we click Finish. And when we do that, it generates all this text for us. You can just type all this text out yourself, too. And honestly, once you've done it once or twice, you can just go back and copy and paste some of this. I copy and paste a lot. No reason to type this out more than once in your life. Once it's there, copy and paste it, and put it in, and then revise it. It's telling us, this little box will pop up and say, just so you know, you don't have a model yet. And we say, I know. And we click Next. This, in M+, it can only read 90 characters on one line, which is pretty short. So that normally works out to be right about here or so after the question mark. In this case, it went a little bit longer, but it won't read anything after 90 characters. Why that is, I don't know, but it is really annoying, isn't it? So you just make a lot of lines that if it goes past 90, it just says, I'm not going to read that anymore. So right about here-ish, don't go longer than that. All right, these are our M+ commands. The names are is a really important line. Did we talk about how to run M+ in September? This feels vaguely familiar. I think we might have. Oh, did we just do Amos?
I think so.
Okay. All right, maybe that sounds like it could be right. I don't remember anymore. But because on our DAT file, it's just a bunch of numbers separated by tabs, it doesn't know what those variables are. So the way it knows what they are is we label them, names are, and we write the variables in order. The order is super important. We could call this giraffes and frogs, and it would still run it okay. It's just our own made-up label for it. Just because we call it men's relationship quality doesn't mean it is men's relationship quality unless it's the very first variable in our SPSS data file. So I copy and paste, and so do our students. So we just copy and paste all of our variables, and then we just copy and paste that into here, so you don't have to rewrite it out. And then you know it's perfectly in the right order. All right, every line in M+ needs to end with a semicolon. So this is just zooming in on this part. Then our names are to list out our variables. This is a super tiny data file. Most of the time your data files might have lots more that you put over. This use variables is just the variables that are in your model. The missing are all -99s. ID variable is ID, letting us know that it's not a real variable, it's just how we numbered our people. I've worked on a couple papers with pro-social and sacrifice. I honestly just like it. I think it's There's lots of different types of love and relationships, but I really like the idea of giving up what I want for me to try to make my partner happy. So I like to find data sets that have a variable like that. With the pro-social stuff I did with the Iowa data, pro-social behaviors, which is observed and coded for how much you were observed in a 25-minute interaction with your partner as you're fighting about something, for how much you give up what you seem to want to try to make your partner happy. I know a lot of people call that you're giving in and flaking out, but you can also call it pro-social. But anyway, in this model, we're looking at wives' sacrifice to husbands' perceived support to husbands' marital quality. This is actually a dyadic model, but with both partners' reports for both. I just tried to make it super simple with 3 variables. So in our model command, we write on statements, outcome on predictor. This is outcome on mediator, mediator on predictor. And this zoomed in quite a bit. Type is missing. We have to replace the missing with general. This is just because they haven't updated the language generator for a long time. All right. For time purposes, I found in previous years that about half of people, when they make their own M+ syntax, it didn't work in the amount of time we had, and then people walk out with their heads low of, I can't do it. And it wasn't that they couldn't do it, just we ran out of time. So if you could open up an M+, if you're there, it looks kind of like this little picture here. Could you click this folder, open, and once you've opened it, if on the flash drive, if you could go to where the flash drive is saved, could everybody take mental note for a minute of where your flash drive is saved? Is it a drive labeled D, E, F, or G? Because we're going to need that letter in just a second. So notice when you're opening up the flash drive, is that in your D, E, F, G drive for how it's labeled? It's in a folder called Med Mod, like this here, for mediation and moderation. And then I want you to open the file labeled M+ input syntax for 3 vars, variables. Sounds like an accent, vars. If you roll the R. All right. Do you have? Mm-hmm.
Yeah, the Mac. I know. I have trouble finding it.
Well, it does work on a Mac, but it's giving you some grief.
I can't even find there's so many. The jump drive. I can't locate it.
Red Bull. That's a good idea. Huh. It doesn't want to find it? It doesn't give you the option to look for a...
Yeah.
Could you save it onto your desktop? Would that work? If you go into the mediation moderation folder and find this file, M+ input syntax for 3 vars. Oh, actually, never mind. Never mind. That's not going to work. How many of you have Macs? Oh, there's apples everywhere. Everywhere. It's just me.
What's the name of the file we need?
The file you need is this M+ input syntax for 3 vars. So it's this syntax here. It's just already prepared for you. So you could just, if you can open that in anything else, and then copy and paste it into M+.
Save it to the desktop.
Yeah.
Okay. Does that work? Could you save it to the desktop and open it up? Do you have it, Dee? Oh, you've got it? Is it working over here? Yay! All right, good. Who has it on their screen on M+ right now? 3 computers? Who has this syntax on your screen? You got 4? There's a pattern. It's just the apples that aren't working. I'm sorry.
I know how to do it. Just drag the, go to the...
Can you drag it into the editor?
No, well,
Is Apple just way cooler than a PC? I'm like one of the only people still using it. They last longer too? Huh. Well, I want it to last longer. Viruses are bad. Wow. That's really good. 10 years? Wow. All right. How are we doing? Can you put your hands up again if it's up on your screen? Yeah? All right. Was that almost everybody? And Dan's helping out there? I love IT, good tech people, because I'm so not good at it. All right. If we're there, okay. So see right here, do you recognize this line on your syntax? It's the third line. All you need to do is change this D. This is the name of what it was on my computer. But where your flash drive is plugged in, you might need to change it to the letter that corresponds to whatever that flash drive is, if that makes sense. If it's saved to your desktop, you need to, this command line needs to be associated with your desktop. All right. So far, so good. I'm a little nervous. Hoping it will work. All right. If you could click Save and give it a name, and then run it. I have a fear for our apples in the room, but I'm hoping it works. It's probably better if I did this on an apple, and I bet it works better for the apples then. So everybody has it up? Is it saved? Did we click run, this blue square? Did that work? Actually, sorry, before you run it, anybody run it yet?
No.
Okay. Before you run it, can you see on the line, just real quick going through, it's the title. If you're just writing it out from scratch, which you can do as well, give it a title. Right where the data is, this is its line of folders that it's in to find that data file, the DAT file we made. The names are, use variables are, we talked about this part. The analysis, this specifies what type of model we're going to be running, specifies what we're using maximum likelihood estimation, that it's going to iterate 1,000 times to try to come up with the best estimates, that it has to converge at this level before it stops estimating. Our model specifying what's predicting what, and our output, asking for what types of output we want, sample statistics, modification indices, standardized betas. I know this is super fast, so I hope that everyone gets a chance to have a full class on it later. But this is the ultra quick version. All right, so if we run it now, all right, I'm scared. Click run. And you should have a black box that pops up that says Bootstrap 1, Bootstrap 2, all the way down to Bootstrap 2000. No? Any apples working? Poor apples. You know, those laptops may never die, but they have their other. Okay. Before we troubleshoot that, could I have everybody look up here again? So if we were to run that without the bootstraps, what you have on yours is with the bootstraps. But if we wanted to add 2,000 bootstraps to this model, I love how easy stuff is in stats. When you know what to type in, it's all painfully easy to do. But if we want to bootstrap it 2,000 times, just write bootstrap equals 2,000. That's all. Check on bootstrapping. Yes, yeah, exactly. If you have a big model, it might take you a long time to run, hours or days if it's a slower computer. But one of my students taught me, if you put a comma between the 2 and the 0 in 2000, it will only bootstrap 2 times. So don't put the comma in. I was doing that for a little while, like, man, my computer's gotten so fast. But I was only doing it twice, not 2,000. So no commas. We add in this model indirect command from the predictor, IND, to the outcome. And it will add in all possible indirect effects between that predictor and that outcome. And then in our output, we add, for the confidence interval, we write C interval as the command. And in parentheses, we write BC bootstrap for the bootstrapped confidence interval of those indirect effects. And that's what you have right now. It's typed in for you. How many of you did it run? Yeah? Check and a check. The HPs and the Dells. All right, did it work over here? Yeah? Okay. It's only apples then? I'm sorry, Apple folks. You're just as good as everybody else. Just, I bet if I made it on an Apple, it would have worked for Apple and not for the PC then. So what is its error is it saying on the Apples?
I can't figure out where it's saved for me.
Because it was on the...
The drive, I don't know if it's C or D or E or what.
For what the desktop is? Was it all saved to the desktops? Is that how we did it?
Put the data on the desktop, maybe?
The data? Like
The DAT file.
The DAT file? Okay.
Sometimes
Yeah.
the Apple paths are just different, like the line of them. I
Yeah.
bought a PC after my first year of having an Apple.
That's funny. You're making me afraid to transition to Apple. But yeah, well, the reason it's not running is it can't find the DAT file. So it doesn't know where the data is all. But everything else is good.
Yeah, it's stored.
All right, raise your hand if you have your output on your screen. Keep them up for a minute. All right, could you gather around somebody who's worked? So you can look at their output. It's harder to read on the screen. I have it up here, but it's hard to see. All right. So at first we go down just a wee bit. You see where the model fit information is? So we want a chi-square that's non-significant. So this 0.495 for our chi-square and p-value of 0.48-ish. It's pretty good. So our chi-square is non-significant. Good fit here. Our MSCA is 0.000. We want it to be less than 0.05. The confidence intervals that we were just talking about around the RMSCA goes up really high, up to 0.17. That's not so good. The CFI is really good at 1.0, and the SRMR is really good at 0.01. We talked about these in September, but I know it was a long time ago now. And we go into our results. If you go down a little more, these estimates here under model results are unstandardized betas for husband's perceived support to husband's marital quality and wife sacrifice to husband perceived support. We would write our lowercase b equals this and this when talking about these paths. These are our t's, estimate divided by the standard error, and our p-values, anything less than 0.05, significant here. All right, our intercepts, we don't normally report in the paper. Our residual variance lets us know if there's more variation that can be explained in these outcomes. And there is, in this case, is significantly more variation to explain. The STDYX is the standardized outcome and standardized predictor. If you're running a moderation in M+, there's also STDY and STDX, where it's only standardizing the outcome or only standardizing the predictor. Since we already standardized our predictors when we made those z-scores, we only want to look at the output of STDY because it's only the standardized outcome and not re-standardizing a second time our predictors that are already standardized. But here's our standardized betas here, the capital B that looks silly in this font, but normally there's a little hangy-do there. Our R squared, 3% variance explained for husband perceived support, and about 48% of our variance explained for husband's marital quality. And our 2,000 bootstraps that we just did, oops, here it is, went too far ahead. If you go down a little bit, do we see this part of your output? This is our total indirect, specific indirect effects. But this specific indirect effect here, it's written kind of backwards. This is our order of wife sacrifice, predicting husband perceived support predicting husband's marital quality. So this indirect effect, if we had more stepping stones, they'd all be listed there. And it would be testing that indirect effect through all of them. If we had lots of indirect effects, and some of your models will have lots of them, they would all be listed out here. This was just supposed to be a simple example with just one. But this indirect effect was negative 0.19. So his wife's sacrifice increased 1 unit on this scale. Husband's marital quality was expected to decrease negative 0.19 units through it. Husband's perceived support. And this was significant according to this. And this is where a lot of us, I think, get a little confused. It says it's significant indirect effect here, but this isn't the bootstrap indirect effect. This is just from what it did looking at that one indirect effect. So what we want to do, and this is standardized indirect effect, one of our other students asked me if they should be putting more weight on because standardized betas mean more for a direct effect because it gives us a sense of the effect size. And he's like, should we be reporting standardized or unstandardized? Like, I don't know. I reported standardized my first few papers. But I asked him to email Chris Preacher almost as a joke. See, but he did, and Chris Preacher emailed back and said, I like to report the unstandardized indirect effects. Because the standardized, it kind of shifts it based off of the distribution of the variance in each variable, and he says it's more accurate. So ever since then, just the unstandardized indirect effects. From the person that made bootstrapping popular as a doc student. All right, but this is our most important part. The reason why we bootstrap it is so we can get that confidence interval of the 2,000 different indirect effects, and of the 2,000 indirect effects it estimated from sacrifice to perceived support to relationship quality. This is our estimate here. If you remember it from a minute ago, this 0.193, that was the indirect effect. Multiplying this beta by this beta, we get this negative 0.19. And this upper 0.5% and this lower 0.5%, that's the 99% confidence interval, right? The 0.5 at the top, the lower 0.5 at the bottom. In our field, we normally do an alpha of 0.05. We normally do a 95% confidence interval. So that's this upper 2.5 and the lower 2.5. And if you have a lot of indirect effects, it's going to show you lots of those indirect effects. They'll all be lined up down here. But here, we've got our point estimate of negative 0.19. And on the lower end of our confidence interval, it's this negative 0.37. On the upper end, it's negative 0.03. So is 0 included in this confidence interval? 2 negatives means no. 2 positives would mean no. But so 0 is not included in this indirect effect confidence interval. So we're 95% confident that there is some indirect effect between these three through those 3 variables. And we would report it. This would be our most important piece of the output. We might say in a sentence, this predictor to this mediator to this outcome is a significant indirect effect. And in parentheses, we would write this unstandardized beta. Lowercase b equals this negative 0.19, comma p less than 0.05, and then the CI, 95% CI, and then we would write negative 0.37, comma negative 0.03. And that confidence interval is really this most important part here of if that includes 0 or not. And what's really confusing and goofy, and honestly hard for me to explain what we're supposed to do with that, is every now and then there's been a couple students that this indirect effect here will say it's significant or not significant, but on the bootstrapped indirect effect, it goes the other way. The bootstrapped one is technically the one we were supposed to put more weight onto for if that one's significant or not. They normally say the same thing, but sometimes if it's really close, it doesn't always say the same. All right, here's another random model our students run in a class. The latent variables of behavior to sex, to marital alternatives, to marital quality. And here's the same model, just a little bit prettier without the indicators. And this would be how we would run that same model in M+ with latent variables and with those paths. These would be all these indirect effects. There's 4 sets of indirect effects here, or 3 maybe, sorry. And then again, we're looking for these 95% confidence intervals, but they're all negative. So all of these indirect effects are significant from behavior to sex, I don't remember what sex, sexual behavior to sexual satisfaction to marital alternatives to marital quality. So that indirect effect is all significant. And each of these indirect effects from here to here to here, here to here to here, and the bigger one here to here to here is all significant. But we can test them all at once in that one model. And I think that was the main gist of what I wanted to show you with the bootstrapping. I wanted to show you a couple more fancier things, and then we'll close off. Do we have like 10 more minutes? How are we doing? 4. I only need 3.5. All right, you can sit back down. I'm sorry for the Apple folks that it didn't run. I need to make it on an Apple too somehow so it can work for you. But we write up our M+, and we make our DAT file, we write our M+ syntax, and here's how we do that. And then that's what we're looking for in our output. All right, an actor-partner model, actor and partner effects. What's kind of cool is that we can do dyadic interactions. So the condition that mom does this and dad does that, that's kind of cool to me. This paper we just published with Christy and John, YouTube programs. So our main effects of mother's relationship quality, father's relationship quality, for co-parenting and stress, which isn't so super interesting for this. This is in JMFT a few months ago. But this is our interaction effects of actor interactions, of mom's co-parenting with mom's stress, dad's co-parenting with dad's parenting stress. And then we've got partner interactions between both partners co-parenting and both partners parental stress. And we had lots of interactions predicting moms, none predicting dads. So that was sort of interesting. But this is our little figure. But here we've got mother's parental stress and father's parental stress and mother's relationship quality. What was really interesting to me is that direction of effects are different for those that are in the condition of low father stress or high father stress. But when moms are really stressed in this condition, where moms have exceptionally high parental stress, feeling overwhelmed with their newborn, they are not impacted at all by father's stress. Isn't that interesting? So, you know, normally we talk about actor and partner effects of this and that, but it's not just actor and partner effects. Now we can qualify when are those actor effects significant, when are those partner effects significant, and when are the partner effects not significant. Isn't that, so you're doing an actor-partner model, but if you put some interactions in yours, Dan, we could test under what conditions did this partner effect work out better than conditions where it didn't. But here, to me, it was just very interesting. So I have a new theory based on just this one model, that our partner effects might only really show up if we're not overwhelmed ourselves. In conditions of low stress, in that condition where mom has low parenting stress, there's a wide range in terms of how much she can be affected by the context of dad's parental stress. So I hope when you're doing your future actor-partner interdependence models, you'll be thinking about not just actor and partner effects, but under what conditions are these actor and partner effects most pronounced, most salient. All right, dyadic mediation as well. In this model, just an example, but we can have predictor, mediator, and outcome for both women, men, and heterosexual couples. Here's an example of how to report that. And this is an example of moderated mediation. It's always just slapped on here at the end, but it took me hours to find an example that would work out significantly for you. But this is the real data. But this, it honestly doesn't mean much. This isn't a paper I would publish, but this is a statistical example. This could be an indirect effect from marital alternatives. If you have other partners out there you're considering, how that's linked with your relationship quality and whether or not you're thinking about getting divorced or separated. And that can be changed by sexual satisfaction as well. All right, and there's the output that it works. And that's it. All done. Really fast for the last 20 slides. Thank you. I'm sorry we had technical problems, but you were great.
Yeah, thanks, Jared.
Thank you.
4 hours of stats in the evening.
Hey, it was earlier than AMFT, like 2 by 2 hours, so much easier to do. Yeah, that was like 8 or 9 o'clock. Yeah.